This is question 30 of the 2025 HSC chemistry trial paper from CSSA that you guys requested. Let's have a read of it. A 0.10 molar solution of silver acetate was prepared. A solution of silver sulfate with unknown concentration was slowly added to 40 mils of the silver acetate solution of known concentration with mixing. After 20 mils of the silver sulfate solution was added, a faint precipitate could be detected. Determine the molar solubility of the silver sulfate solution, assuming that the added moles of silver ions are negligible compared to the number of moles of silver ions in the silver acetate solution. Okay, now a few things I want to draw your attention to before we even do the question, just to make sure you understand the question perfectly and we don't have any issues when you go to do the actual calculation together. Yeah? First thing to keep in mind, you've got two different ionic compounds in the question. Normally, when you get two different ionic compounds, the instinct is to be like, oh, mixing ionic compounds, the ions are going to swap, you're going to make a precipitate, right? That's what normally happens. That's what you're used to. However, in this case, a precipitation reaction will not happen because you've got the same silver ion in both ionic compounds. They don't need to interact with each other. Nothing new is going to get formed. All right. So if you imagine yourself, you can go ahead and treat it like a precipitation question. If you imagine yourself swapping the names, silver acetate with silver sulfate, you're going to get the same names by the end of it, silver acetate and silver sulfate. Yeah. So it's not going to change. What that tells me is this isn't a precipitation reaction question. When I go to write the equation, it's probably for only one of the ionic compounds, and the other ionic compound just interferes with the existing reaction somehow. Yeah, but I'm not going to write an equation with both ionic compounds in it. Okay, this is a molar solubility question. I will write my equation, my balanced chemical equation for whatever they're asking me for. They're asking you for the molar solubility of silver sulfate. I am going to write my equation for silver sulfate. Okay. When you're calculating for molar solubility, you write the KSP equation out, you set up your ice table, you solve for your X or your letter S, depending on what you like to use. Silver sulfate is Ag2SO4 solid. Whenever you're writing dissolution equations, it's always a solid on the left with the ions that it's dissolved into on the right. Okay. So at the very start, you haven't dissolved all of your ions yet. So it's going to shift to the right to do that. You need to figure out how much can be dissolved at equilibrium. So therefore, you're setting up an ice table. You want to figure out the equilibrium amount. Okay. Normally, when you're doing molar solubility questions, you're very used to being like, oh, I'm dissolving this in water. So the initial concentrations of everything are zero because water is just H2O. There's no Ag plus, there's no SO4 2 minus in there. However, guys, in this question, we already talked about it. You're not doing this in water. You're dropping in the silver sulfate in a silver acetate solution. And we already said that there's a common ion here. Guys, this is a common ion effect question. Okay, this is a common ion effect question. So in silver acetate, I don't have any sulfate. That one is zero. In silver acetate, I do have silver. Okay, so this here is going to be a certain number. I'm not going to fill this in as zero. Okay, so I have to figure out what that number is. Yeah. Now, please just keep in mind that your ice table, you normally do concentration. You normally do concentration. This, however, guys, this common iron effect question is slightly different to the ones you're used to doing. When you normally get asked for common iron effect questions, let's say like I gave you, this is year 11, let's say I gave you module 5. These are the common iron effect questions you're used to. Yeah, so it's just like calculate the molar solubility in a 0.05 molar solution of something else. Yeah, they just give you the concentration straight up and there's no mentioning of whatever the volume is. All right. So when they do that, it's sort of like you're dissolving a solid in the solution. And then when you dissolve a solid in the solution, it's basically just the volume of the solution. So in this case, it would be the 40 mils. Yeah. So you don't have to worry about the volume changing in those cases because you're just adding a solid. So the concentration of the silver basically stays the same throughout because it's in the same volume the entire time. Yeah. The issue with this question is this. You start off with a 40 mil silver acetate solution, but you're not adding in a solid, you're adding in drops of silver sulfate volume until you get up to 20 mils. Yeah? Because you're starting off with 40 and then you add one and then you add another one, then you add another one until you get up to 20 mils. When you increase the volume, concentration decreases as you go. Okay, if you increase the volume in the denominator, concentration decreases as you go. So, guys, as you add the drops of silver sulfate, okay, as you add the drops of silver sulfate, I know you have some silver ions already there. I can't figure out the concentration because the concentration is always changing. Okay, guys, I would rather do this in terms of moles because concentration will progressively change as you add the 20 mils. Yeah. The only time I'm certain about concentration is when I'm done adding in all 20 mils, and there is definitely a total of 60 mils at the end of it, and then there's no more volume changes after that. Yeah. But for now, I'm gonna set up my ice table in terms of moles because I don't want to have to deal with the changing volume. Okay. So you start off with the amount of silver you have at the start. It's a 0.10 molar solution. You have 40 mils of it. So moles of Ag plus is the moles of silver acetate. It's a 1-to-1 ratio. How many moles did you have at the start? C times V. 0.10 molar times 0.04 liters. 40 mils is 0.04 liters, and that'll be 0.04 mole. Okay, so that's my initial moles of silver. Your equilibrium shifts to the right, plus 2x plus x, or s if you like to use s, 0.004 plus 2x with another x. Guys, if you're solving for molar solubility, which is that x, then you need to know your KSP. So what we've talked about before is you either know molar solubility or you either know KSP, all right? You can't have both unknown. Okay, if the question's asking you to solve for KSP, you have to know molar solubility. If the question's asking you for molar solubility, you have to know KSP. That doesn't mean they have to give you KSP because you can find it in your data sheet. Okay, so my equilibrium expression for KSP, products over reactants raised to the power of any coefficients. Pure solids I don't include, so I'm not going to divide by the Ag2SO4. This KSP isn't given to you in the question. We must be able to find it from the data sheet. And silver sulfate is your very last one in your HSC data sheet. Silver sulfate is down here. It's 1.2 by 10 to the minus 5. Okay. Now, guys, they told you to make an assumption. What they told you in the question was this. They told you that you can assume that the added amount of silver, oh, hold on, that the added amount of silver is negligible compared to the moles of silver ions in the silver acetate solution. Now, to be completely honest with you, that assumption to me kind of seems like it's just confusing you. I will tell you what it means. I'll tell you what it means, yeah. But you'll notice that when I go back to the calculation, you'll notice that you were gonna make that assumption yourself anyway. They did not need to tell you that in the question. Okay, guys, what they're basically saying is, you know how you're adding in, you've got an existing solution of silver sulfate, sorry, silver acetate, and then you're putting in drops of silver sulfate as you go. Yeah. What they're basically saying is the added moles of silver from the silver sulfate here is negligible. Basically, ignore any silver that came from silver sulfate. So pretend like all of the silver in the beaker only came from the silver acetate. AKA, ignore the silver part of the silver sulfate and focus just on the sulfate. Okay, which sounds really confusing. It's like, why are they telling you that? Guys, they're basically saying that the amount of silver doesn't change, right? So you know how you add silver from silver sulfate? They're basically saying, forget it. Okay? The amount of silver you had at the start is the amount you're always going to have. Ignore any extra that you get. Guys, which was what you were going to do anyway. Okay? So you've got here, you get to this point here. Okay? This is your equilibrium amounts of both. This is your silver, this is your SO42 minus, all right? Normally, we've done questions before. Whenever you have X with another number, you tend to assume that X is way smaller than the other number. Yeah. So you're like, oh, KSP is very small. Assume that any X with another number is way smaller than that other number. 2X is way smaller than 0.004. So therefore, 0.004 plus 2X is basically just 2X. Sorry, it's basically just 0.004. Okay, ignore the 2X part. Right? You're used to making this assumption. That's basically what they're telling you, yeah? Because 2x is the amount of extra silver that you added. They're basically saying just focus on the 0.004, ignore any added silver, ignore the 2x. You were going to do that anyway. The sentence is long and they're mostly just to be confusing, okay? Remember, you're only assuming x is negligible relative to another number. I'm only ignoring the x in the bracket with a 0.004. I'm not ignoring this x, because if I ignore every x, I'm not going to have an x to solve for, right? You're only getting rid of the x in a bracket with another number, okay? So this, the silver concentration is, the silver moles, sorry, the silver moles is basically just 0.004, yeah? And then you pop it into your equilibrium expression. Just keep in mind, we've been doing this in terms of moles. If you're going to pop it into your equilibrium expression, you need to do it in terms of concentration. All right. So guys, the reason we didn't do it in terms of concentration again was because the concentration was changing as we went. Okay. It started at 40, but you were adding drops continuously up until you got to 20. At equilibrium, though, I'm okay. Why? Because the change in volume was for the process to getting to equilibrium. Yeah, it started at 40, it was changing, going up to 20. Now that we're dealing only with the equilibrium and we're not concerned with the ice table anymore, now that we're only taking these numbers at equilibrium, the reaction's done. You finished adding the 20 mils. Okay, you are done adding the 20 mils, which means in total, by the time you finish the reaction, by the time you get to equilibrium, it's a total of 40 plus 20, which is equal to 60 mils. All right, so these numbers here, this 0.04 plus 2x with the x, that's all at 60. Okay, so when I pop it into the equilibrium expression, it's going to be moles over volume, and the volume is going to be the total 60 mils now that I'm done with the reaction. Yeah, so it's going to be 0.04. Remember, I neglected the 2x. Divided by 60 mils is 0.06. And remember, squared, raise to the power of the coefficient. And then for the sulfate, that's x on 0.06. It's okay that I have it as x. Remember, the question's asking me for molar solubility. I'm actually looking for that x. Is 1.2 by 10 to the minus 5. And guys, if you evaluate the 0.004 divided by 0.06, you'll get like a 0.067. It's repeating 0.06. Squared x on 0.06 is equal to 1.2 by 10 to the minus 5. Rearrange this to solve for it, multiply the 0.06 over, and then divide by the 0.067 squared. So remember, x is your molar solubility, yeah? Is going to be 1.62 times 10 to the minus 4 mole. The only difference is this, okay? When you normally set up your ice table in terms of concentration anyway, yeah? You normally set up your ice table in terms of concentration. So when you solve for x in those normal questions, the x that you get is moles per liter, which is exactly molar solubility. The only issue is though here, again, we did it in terms of moles because the volume was changing. Because we did it in terms of moles, your x is also moles, right? So guys, this is the moles dissolved. This isn't necessarily molar solubility though. This is the moles dissolved, but molar solubility is moles dissolved per volume of solution. Okay, molar solubility is moles per liter. Yeah, it's not mole. Okay, so once you've got an X here, you need to divide it by volume again to get the actual concentration dissolved. Okay, so that's the amount dissolved. The concentration dissolved is 1.62 times 10 to the minus 4 mole divided by What volume are we in? Again, remember, we're in the total 0.06 liters. Yeah. The 1.62 times 10 to the minus 4, that's the total amount that you dissolved in the total 60 ml of solution. So 0.06 liters will give you a molar solubility of 2.7 by 10 to the minus 3 mole per liter. This is your molar solubility. Okay. Now, guys, this is a CSSA question, the paper that most of you guys sat. Yeah, if you happen to have gone through this exam question with your teacher, if they went through the trial paper with you, or if if they've given out the answers to you and you've seen it, then guys, the CSSA paper solution, they actually didn't divide it by 0.06. They divided it by 0.02. Okay. The 0.02 is the volume of the silver sulfate added. Yeah, so the question is asking you for the molar solubility of the silver sulfate. And then the 20 mils is the volume of the silver sulfate. Yeah. Here's the thing though. So let me just make a note. This is our answer. And then this is what CSSA did. CSSA, they did 1.62 times 10 to the minus 4 mole. And then instead of dividing it by the total volume that it was dissolved in, they divided it by the volume of the silver sulfate, which is 0.02 liters. And then as a result of that, they got 8.1 by 10 to the minus 3 mole per liter. Okay. When they did this though, keep in mind what the question's asking you for is molar solubility. Yeah, how much is dissolved? When they did this, when they divided it by the 0.02, they didn't label their answer as molar solubility. What they did was this, they labeled it as quote unquote, which means taken directly from the thing, the original concentration of unknown Ag2SO4 solution. Okay? Which means what they've calculated is the unknown concentration of the silver sulfate, right? Because remember the question said the silver sulfate concentration was unknown. So at face value, it kind of seems like they haven't even answered their own question. They're not calculating molar solubility. Okay. The other way of thinking about it is this. The other way of thinking about it is this. Guys, the concentration that they've calculated, they've got the total amount of sulfate, right? Listen carefully to this part. They've got the total amount of sulfate dissolved in the total volume of the sulfate solution. Okay, they've got the total amount of sulfate dissolved in the sulfate solution because 20 mils is the volume of just the sulfate. Yeah, so what they've effectively done is that's the molar solubility. Guys, the sulfate solution, though, before it mixed in with the silver acetate, the sulfate solution would have been an aqueous solution. Yeah. The sulfate solution before they mixed it in with the silver acetate would have just been an aqueous solution. So if they took, guys, if they took the sulfate moles over the sulfate volume, that's just the molar solubility in water. Okay. So they're taking the total moles of sulfate over the volume that the sulfate is in. The sulfate is presumably dissolved in water, and that's only the 0.02. So what they've done is calculate the molar solubility in water. Okay. However, here's the thing though. The question never implied that they wanted the molar solubility in water. They just said determine the molar solubility of the solution, and then it happened inside of a silver acetate solution. Okay, it happened inside of a silver acetate solution. So if you divide by the 0.06, that's the molar solubility in the silver acetate solution, which is a common ion effect question. And then if you divide by the 0.02, that's the molar solubility in water, which is why if you have a common ion, then the solubility decreases, which is why our answer is slightly smaller than their answer. Okay? The question never implied it though, where they wanted the molar solubility to be calculated in.